This is part 1 of section 4.6, complex zeros. We will start with the fundamental theorem of algebra, page 236, if you'd like to go back. Every complex polynomial function of degree n is greater than or equal to 1 has at least one complex zero, which kind of makes sense. A complex polynomial function has at least one complex zero. Okay, we're going to focus today on complex zeros and how you can solve polynomial equations that have complex zeros. So the first thing that you need to know, keep in mind, is that all complex zeros come in conjugate pairs. So what's a conjugate? A plus bi, a minus bi. Should probably learn to put my phone on silent, huh? A plus bi, a minus bi. Where does a complex answer come from? Well, first, a complex number. Square root of -1 is imaginary. So complex numbers come in the form with a real and an imaginary number is from the square root of -1. So for example, if you know that, how about 3 plus 2i is a solution, that means, therefore, 3 minus 2i is a solution. Well, let's work backwards. When you get an imaginary answer, it's because you have a negative underneath a square root. An imaginary answer must involve a negative underneath the square root. And when you solve, what formula do we know that involves solving with square roots? And that would be the quadratic formula. So when you use the quadratic formula, right, opposite of b plus or minus the square root of b squared minus 4ac all over 2a. What's underneath the radical, if that's negative, you get an imaginary answer. Well, the only way to get the imaginary answer is with the square root, and the square root comes from using the quadratic formula, and the quadratic formula always involves plus or minus, two answers. So that is why if 3 plus 2i is an answer, so is 3 minus 2i. Okay, so let's work backwards, and I'm going to give you a solution, and you're going to give me the polynomial. So up until today, you were doing P over Q, Descartes, upper bound theorem, and you were solving and finding the zeros. Now I'm telling you, here's a zero. Let's find the equation. So if I tell you that x equals, let's just do 3 plus 2i. This means, therefore, 3 minus 2i is a solution. Okay, there are a couple ways that you can work backwards and find the answer. One is subtract 3, subtract 2i. This is the factor. And then I'll put equals x here. Subtract 3, add 2i. Again, know the difference between your factors and your solutions. All right, well, what do? You multiply the two factors together, and there are a couple ways you can do this. Some of you just go ahead and do the whole distributing. You go through and you distribute x times x times -3, x times 2i, and then distribute the -3, etc. Some of you do the box. Didn't leave myself quite enough room. This is a very small box. Sorry. X minus 3 minus 2i, x minus 3 plus 2i, and you fill in the box. I don't care which way you do it. There's a great trick. There's a great trick from Algebra 2 Honors. And the trick from Algebra 2 Honors says that solution 1 plus solution 2, opposite of that is equal to b over a, and their product is equal to c over a. So if you didn't see that last year, I am telling you that I personally think this is great. BA, where's that all come from? Comes from the coefficients on the quadratic, ax squared plus bx plus c. Y equals f of x equals whatever. So in this particular problem, their solutions are 3 plus 2i, 3 minus 2i. The i's will always, always, always reduce out. That's why I like it. Solution 1, who cares? I'll call it 3 plus 2i. Plus solution 2, 3 minus 2i. Bye-bye, you get negative 6. That's the same thing as negative 6 over 1. Their product, it's difference of two squares. Distribute, 3 times 3 is 9. Minus 6i plus 6i gone. Minus 4i squared. I squared is negative 1. You don't have to show all this, so that's 13. So 13 over 1 is c over a. I know you're wondering what happens when a isn't the same. I'll show you. So a is 1. B is negative 6. C is 13. Okay, two things. One, you'll get the same exact answer, assuming I didn't make a mistake, because I don't think I did. You will get x squared minus 6x plus 13 if you just do flat out distributing, if you use the box, or if you do b over a, c over a. You should get same answer. But here's the part that, and this costs some of you points on the midterm. Equation must have an equal sign. An equation must have an equal sign. If you forget it, you're going to lose points every time. You're going to lose points every time. Okay, let's look at another one. I'm going to pull a problem from the book. I want a polynomial. Example 2. Degree is 4. I am giving you zeros at I and 1 plus 2i. I want you to tell me, find the polynomial of 4th degree with zeros at I and 1 plus 2i. All right, I'm going to start with the I. So if x is equal to I, therefore x is also equal to negative I. These are solutions. That becomes x minus I. That becomes x plus I. I don't do b over a, c over a when it's a monomial solution. Binomial solution, then I tend to use more shortcuts. This is a monomial. Multiply it out, and this is x squared plus 1. Negative I squared. I squared is negative 1. And by the way, you can always do a quick check, set it equal to 0 and solve. Okay, 1 plus 2i. So that means 1 plus 2i is a solution. That's a 2, sorry. And x equals 1 minus 2i. If you want to, okay, so this is where you can do the box or the distributing, whatever. If you decide to multiply it out, be careful. It becomes x minus 1 minus 2i times x minus 1 plus 2i. Set this equal to 0, subtract 1, subtract 2i. Set this equal to 0, subtract 1, add 2i. Multiply it all out, use the box. I'm going to do b over a, c over a. So this is my solution 1. This is my solution 2. So b over a is equal to the opposite of their sum, 1 plus 2i plus 1 minus 2i, which is negative 2. Every single time you add, the i's will zero out every time. If conjugate pairs are a plus bi and a minus bi, when you add them together, plus bi minus bi every single time, that's going to be 0. And then c over a is going to be their product, 1 plus 2i, 1 minus 2i. 1 times 1 minus 2i plus 2i. Every single time when you distribute, those are going to zero out. Minus 4i squared, which becomes 5. I squared is negative 1. Negative 4 times negative 1 is 4. Add. So I'm going to get my function is equal to x squared minus 2x plus 5. Let's do a really quick check since we're here. Let's do the quadratic formula. So yesterday, last week, whatever day it was, when we were doing section 4-5, or whatever, algebra 1, and I ask you to solve, I ask you to find the x-intercepts, the zeros, whatever. You would do x squared minus 2x plus 5 equals 0. The discriminant is negative. Discriminant b squared minus 4ac is negative. Your only choice is to use the quadratic formula. 2 plus or minus square root of b squared is 4 minus 4ac all over 2a becomes 2 plus or minus the square root of negative 16 over 2. That's 2 plus or minus 4i over 2, which is 1 plus or minus 2i. Always come in conjugate pairs. The only way to get a complex solution is to get a negative under the root sign. And the only way to solve when you have a negative discriminant is to use quadratic formula, which always results in plus or minus. If you choose to use b over a, c over a, let me just do one final thought on that. Let's say you're doing b over a, c over a, and you end up with b over a equals, let's just say 2/3, and I'm totally making this up. C over a is 1/6. Clearly, a is different. A can't be 3 as well as 6. So you need to multiply this by, right, 2 over 2 to get the common denominator. Now a would be the same. So whatever this is, so 6x squared, a is 6, b is 4, c is 1. that's how you would do it if, for whatever reason, the denominators weren't the same.